Our I can statement for today is E5. I can solve two-step equations. This is the last video in this series, so if you haven't already, please watch the 3 preceding videos because they'll be a foundation for the stuff we cover in this video. Let's do a quick check. So take a look at the equation and the solution that's given here. Did the student get the correct answer? So you need to take the value given for r and plug it into the original equation and decide, did they get the correct answer? Yes or no? All right, so remember to plug it back in. We're looking at 26.55 equals 16.23 plus 2 times negative 2.4. Now we already know what this side equals. It equals 26.55. So we're going to type into our calculator 16.23 plus 2 times negative 2.4. And we get 11.43. Now, what does that tell us? Did the student get the correct answer? That's a no because the two sides of the equation are not equal. So if this happens when you're doing a self-check, you need to make sure that you go back and look at your original work to see where you went wrong because this is an indicator the answer you have is incorrect. So once again, we just looked at why we do the check process after solving an equation. We should never say, well, I don't know, hope I got the problem right, because if you do the check, you'll know for sure. All right, now these two-step equations are different from the ones that we've looked at in the past. And the reason for that is instead of a number multiplying our variable is being divided by a number. So just as a reminder from our rational numbers unit, the division bar is mathematically equivalent to a division sign. We could rewrite this entire number sentence as 6 equals a divided by 4 plus 2. Okay? So the first step is going to be the same. We're going to start out by subtracting 2 from both sides. Okay? So 6 minus 2 is 4. So a divided by 4 equals 4. The next step is the opposite of division is multiplication. So we're going to multiply both sides by 4. Okay? Now if I multiply this straight across, I get a times 4, or 4a, over 4 times 1, which is 4. So I get 4a divided by 4. However, remember when we're cross-canceling, we can cancel out a factor of 4 from the top and a factor of 4 from the bottom to leave behind a factor of 1. So this is actually the same as 1a over 1, or just a. So when I'm starting with a over 4 and I multiply it by 4, the result is just a. On the other side, I have 4 times 4, which is 16. Let's do the check. So 6 should equal 16 divided by 4 plus 2. And when I type it into my calculator, 16 divided by 4 plus 2 does give me 6, so I know that I got the correct final answer. All right, let's take a look at another problem. So I'm going to find the equal sign and draw a line down. Then I'm going to look for my variable. It's right there. I want to add or subtract any numbers on the same side as my variable. So in this case, since I have a negative 10, I'm going to do the opposite, which is a positive or addition of 10. Okay? So negative 6 plus 10 is going to be positive 4. Positive and negative 10 cancels out. So I'm left with n divided by 2. Now, if I multiply both sides by 2, the 2's cancel out, so I'm left with n on this side, and I'm left with 8 on this side. Now, reviewing really quick what canceling out means. So what I just showed is all that you need to do for work, but as a reminder of why this happens, so we have n over 2. If I multiply it by 2 over 1, I can divide 2 from the top and 2 from the bottom to cancel them out to make 1. Or another way of thinking about this is 2 divided by 2 is equivalent to 1. So I have 1n left over. All right, let's do the check. So I have 8 divided by 2 minus 10, and I want to see, does that equal 6? Well, 8 divided by 2 is 4. 4 minus 10 gives me negative 6. So both sides are equivalent, so this is my correct final answer. Now this one can be a little tricky, okay, but we're going to start it out the same way as before. So I'm going to get rid of everything on the same side as my z. So the first thing I want to get rid of is the 5. I'm going to subtract 5 from both sides. Those cancel out. So I get negative z over 3. And that's equivalent to 4. Now, as a quick reminder over here, we learned that it doesn't matter where the negative sign is in a number. It doesn't change the value to move it around. So negative z over 3 is equivalent to negative z over 3, which is equivalent to z over negative 3. We can write our fraction all 3 ways and it doesn't change the value. So anytime you see a negative sign with the variable, I want you to think of it as being like this. And the reason is because when you go to multiply both sides by the 3, you'll remember that it needs to be a negative 3. Why does it need to be a negative? Because when we multiply or divide, we've got to keep the sign the same. So I'm going to multiply both sides by negative 3. Okay, so negative 3 divided by negative 3 cancels out. We're left with just z. And 4 times negative 3 is negative 12. If we didn't do that, we would instead end up with negative z equals negative 12. And then we'd have to divide both sides by negative 1. So doing it this way saves us a step. Let's do the check. So we have negative, and then our answer, negative 12 over 3. Note that my answer was negative and the original problem had a negative, so that's why I have 2 different negative signs here in the check. And honestly, this is the part where we can make a lot of big mistakes when we're doing the check. If it has a negative and then you're plugging in a negative number. Then we have our plus 5, and we want to see if that equals 9. So we type it into our calculator, and we get 9 for our answer on both sides. So that's how we know that negative 12 is the correct answer. All right, try this one on your own, and then start the video up when you're ready to check your answer. All right, hopefully you're ready to check your answer. Now, I want to address a common misconception. I think that you should know that 2 is the number that we need to get rid of, but there are 2 different ways of thinking about how to get rid of that 2. Some people will see the subtract sign and think, oh, I need to add 2 to both sides. However, the subtract sign, remember, goes with the term that comes next. 2 is actually positive, okay? So the subtract or negative sign is going to go with the b divided by 3 term. So if I want to get rid of 2, since 2 is positive, I need to subtract 2 from both sides. 2 minus 2 adds up to 0. And I'm left with, here's another reason why it's important to notice the term, I'm left with negative b over 3. That negative has to be part of your next step in order to get the correct final answer. Okay? And if you want, you can definitely just write the negative as being part of the 3 instead. And mathematically, those are equivalent, so this just gives you a step in the right direction. Okay, 5/2. Now this is something that's important to note. 5/2 is an improper fraction. So I want you to write it as a mixed number right now. You can use your calculator to help you if you need to. You can type 5 ABC2, enter, and it will tell you that 5/2 is equivalent to 2 and 1/2. And that's going to be important when we do the check. If I have 2 and 1/2, that's negative, and I'm subtracting 2 more from that, I'm going to get negative 4 and 1/2. Okay? And I could have done that in my calculator as well. The next thing I need to do is multiply both sides by negative 3. Why negative? Because we have a negative in our number. So I'm going to multiply both sides by negative 3. These two cancel out because I have times and divide, which are opposites, so I'm left with just b. And then I can type it in my calculator. Negative 4, ABC1, ABC2, times negative 3, and I get 13 and 1/2. Now let's do the check. So I have 2 minus 13 and 1/2 divided by 3. Now it's important to note that if we have a fraction as part of either our numerator or denominator, we can't type this in using the fraction button. So when I type this in the calculator, I'm actually going to type the divide button instead of the ABC button. So in my calculator, that's going to look like 2 minus 13 ABC1, ABC2 divided by 3. When I press enter, I get negative 2 and 1/2. And some of you might be thinking, oh, well that's not the same as negative 5/2. But remember, we already typed negative 5/2 into our calculator, and we found that it equals negative 2 and 1/2. So our final answer is correct. All right, now this one might look a little bit more complicated, and it isn't. Negative 1/2 is still just a number, so you can do all the same steps that we've done with all of our previous problems. So try this one on your own, and then start the video up when you're ready to check your results. All right, let's check our answers. All right, so the first thing I did was add 1/2 to both sides. That cancels out the 1/2, so I'm left with x over 4 equaling 3 3/4. 3 3/4 is the result of 3 1/4 plus 1/2. Then I'm going to multiply both sides by positive 4, so I'm left with x equals 15. Now I'm going to do the check. When I rewrite my original equation but use 15 instead of x, I get 3 1/4 on one side and 3 1/4 on the other side. Since both sides are equal, I know that my final answer is x equals 15. You try problem number 7. Remember that the first number we need to get rid of is the number that's added or subtracted on the same side as our variable. Start the video up when you're ready to check your answer. So, for my first step, I'm adding 5/6 to both sides. That cancels out the 5/6 on the same side as our variable, and I get 1/3 equals a over 4. Then, I'm going to multiply both sides by 4. So, my 4's cancel out, and I get a equals 1 1/3. I plugged my answer back in for the check. Notice that since the top I'm going to use fraction buttons for, I want to do 1 ABC1, ABC3 divided by 4 when I'm entering this into the calculator. Both sides equal -1/2, so I know that I got the correct final answer. All right, let's finish things off with a story problem. You purchased paint for the room in your house. You have 1 1/2 cans of paint left. You painted 4 rooms and each room required 2 cans of paint. You spilled 1/2 of a can of paint. How many cans of paint did you purchase? Now, the 1 1/2 cans of paint left, that's what we're going to consider as our total amount. This is our final amount. Okay? Now, it's asking us how many cans of paint did you purchase? So, I'm going to make that be our variable, which I'm going to say is going to be P. So, I started out with P cans of paint. I painted 4 rooms and each room required 2 cans of paint. So I'm going to say 2 times the 4 rooms for 2 cans of paint per each 4 rooms. And I also spilled 1/2 of a can of paint. So I'm going to figure out how many cans of paint did I purchase. Well, I'm going to multiply the 2 and the 4, so I'm going to get P minus 8 minus 1/2 equals 1 1/2. And then I'm going to combine like terms. -8 minus 1/2 gives me P minus 8 1/2 equals 1 1/2. Okay? And then over here where I have some more room, I'm going to add 8 1/2 to both sides. So my 8 1/2s are going to cancel out on this side, and I'm going to get P equals 10 cans. So the final answer is I purchased 10 cans of paint to start. Take a moment to reflect on the following questions. From this lesson, what is something I need to remember? And what is something I need more help on? And these are the things that you can bring to class to ask during our in-class discussions. Remember, you can watch the video as many times as you need to, pause as you need to, and thanks for watching.